Hi, welcome back to Missing Chemistry. This is Net Ionic Equation Problems Lesson C. Okay, so our problem is barium nitrate is reacted with ammonium phosphate to yield the products barium phosphate and ammonium nitrate. What is the total ionic equation? And then what is the net ionic equation? Okay, first of all, we have to write the equation. So it's kind of like a word equation. So we go barium nitrate, NO3. Now, plus ammonium phosphate, that's NH3PO4, yields barium phosphate plus ammonium nitrate. Okay, well, we know that this is not quite right because this has a -1 charge and this has a +2 charge according to the oxidation numbers. This has a -3, this is a +1, -3, +2, -1, +1. So we have to do what we call a crisscross. So the 2 comes down here and that 1 would go to BA, but we don't write that. Then you would need to do a crisscross here, where you would need a 3 there. And then we would crisscross 3 here, and then we bracket the polyatomic ion, put 2 there, and this last one is okay. Alright, so you should know that from your oxidation lessons earlier this year. Okay, now, so now the next thing we can do is we've got to balance this. Oh, we got 3 barium over here, so we need a 3 here. And then we're going to need a 2 here for our nitrates because we have 2 phosphoruses, ammonia, sorry. And then we're going to need a 6 here because 2 times 3 is 6, so that goes there. So now that's a balanced equation. Now we need to make the TIE, the total ionic equation. I call it the TIE. So we're going to write it like this: 3 BA plus 2 AQ. Well, you know, something else we should have been writing here is our states. This is an aqueous. All nitrates are aqueous. Phosphates are also aqueous for the most part. Okay, but however, with barium, it's solid. And then nitrates are always aqueous. Okay, so we got 3BA plus 6NO3 minus AQ. Where that 6 come from? You have a 3 here and a 2 here, so 2 times 3 is 6. Okay, just kind of keep that in mind. All right, plus 6 ammonias. Okay, that's 1. That's also AQ. Plus 2 phosphates, PO4 minus 3. Okay, and that's AQ. Yields, let's see here, BA3PO4. It's a solid, so you can't break that apart. And then you're going to have 6NH4 plus 1 is AQ plus 6NO3 AQ minus 1. Okay, so now what we need to do, we need to get, that's our total ionic equation. We want to get our net ionic equation, the NIE. So how do we do that? Well, we have to look to see which one's changed from the left side of the equation to the right. Barium went from an aqueous to a solid, so it changed. Nitrate here was aqueous here and aqueous there, so it didn't change. So the first thing I'm going to do is I'm going to get rid of that because it's a spectator ion. Look at this. Our ammonia is aqueous here and aqueous here, so it didn't change. So I'm going to get rid of that spectator ion. All right. Our phosphates are aqueous here and solid here, so they did change. So we don't get rid of those. Okay? So now we're going to write the net ionic equation. So it would be 3Ba plus 2 AQ plus 2PO4 minus 3 AQ yields Ba3 PO4 2. Let's make it better 2 than that. And that's going to be solid. All right. Well, let's look at work another problem. So we have to clear these drawings real quickly. So we're going to have to clear these drawings. Okay, here's our second problem. Calcium hydroxide is added to iron 3 chloride and yields calcium chloride and iron hydroxide. What is its total ionic and net ionic equations? Okay, well, let's see here. We got, let's go ahead and write it out first. Calcium hydroxide, okay, and that's an aqueous solution. So how did I know that was a minus 2? That's minus 1 plus 2, okay. Plus FeCl. And this is iron 3, so that's a plus 3, so that's a minus 1. So that would have to be a 3. And that is also aqueous. Yields calcium chloride, CaCl2, which is also aqueous. How to get a 2 there? Minus 1 plus 2, our oxidation numbers. Plus iron hydroxide, so if that was iron 3, this is a plus 3 here, minus 1, so this has to be a 3 here. And of course, iron hydroxide is a solid. Okay. So now we've got that. So let's make sure it's balanced first. No, not quite. We've got 2 hydroxides here and 3 hydroxides there, so that means we got to put, of course, a 3 in front of here, a 2 in front of, let's see here. Then we would need a, let's see here. Oh yes, we're going to need a 2 in front of here, and we're going to need a 3 in front of here, and of course 2 in front of here. And now we're balanced. One happy family. Okay, so let's do the total ionic equation. All right, let's see here. So we're going to go with tie, T-I-E. I like to call it the tie. So you go 3Ca plus 2 AQ plus 6 OH negative AQ. That 6 comes from 3 times 2. Okay, just to show you that. Plus 2Fe plus 3 AQ plus 6Cl minus AQ yields 3Ca plus 2 AQ plus 6Cl minus 1 AQ plus 2 FeOH3 minus 1 plus 3. And this is solid. So we don't break it apart. All right, now let's see which ones are our spectator ions and which ones are not. Remember, spectator ions go the way of the dodo. All right, so now calcium is AQ here, and it's AQ on this side of the equation, so it goes away. OH is AQ here, but solid here, so it doesn't go away. Fe is AQ here and solid here, so it doesn't go away. Chlorine is AQ here and AQ here, so it does go away. All right, now we're going to write our net ionic equation. Remember, always write the cation, which is the metal, first. So in this case, so we're going to go NIE, our net ionic equation, is going to be 2Fe plus 3 AQ plus let's see here, 6OH minus 1 AQ yields 2 FeOH minus 1 solid. Okay, so let's see here. Let's make sure everything looks good. And everything does look good. Okay, looks great. So that's it for this episode of Net Ionic Equation Problems. You guys be snarly, and we'll see you back here at Moose and Chemistry.